Today, we're diving into the fascinating world of solutions and mixtures. These are fundamental concepts in chemistry that we encounter in our daily lives, often without even realizing it. Whether you're making hot chocolate on a chilly day or putting together a tasty trail mix for a hike, understanding the difference between solutions and mixtures can be really useful. So, let's break it down. First up, solutions. A solution is a type of mixture where two or more substances combine to form a new, uniform substance. This means that the components are evenly distributed at the molecular level. Think about it this way. When you mix hot chocolate powder into warm milk, the powder dissolves completely, creating a single, smooth drink. You can't see the individual particles of the powder anymore. In this scenario, the hot chocolate powder is the solute, and the milk is the solvent. The solute is the substance that gets dissolved, while the solvent is the substance that does the dissolving. Together, they form a delicious solution that is consistent throughout. Every sip tastes the same. Another great example is salt in water. This is a classic example often used in science classes. When you stir salt into water, the salt dissolves, and you can't see it anymore. The salt particles are evenly distributed throughout the water. The salt, solute, and the water, solvent, create a homogeneous solution where everything is evenly distributed. Pretty cool, right? This uniformity is what makes solutions so unique. Now let's talk about mixtures. Mixtures are a bit different from solutions. Unlike solutions, mixtures involve combining two or more substances where each keeps its own properties. This means that the individual components do not dissolve into each other. Imagine making a trail mix with nuts, raisins, and chocolate chips. Each ingredient stays separate and doesn't form a new substance. You can still see and taste each individual component. This is what we call a heterogeneous mixture, because you can still see and pick out each component. The parts are not uniformly distributed. This is what makes mixtures so interesting. You can have a variety of textures and flavors all in one bite. Another example is a salad. When you toss together lettuce, tomatoes, cucumbers, and dressing, you get a mixture. You can still identify each part of the salad, and they don't merge into a single uniform substance. Each ingredient retains its own unique properties. That's the beauty of mixtures. All the parts coexist without losing their identities. You get a colorful and diverse combination of ingredients. So, to sum it up, solutions are uniform and homogeneous, like our hot chocolate and salt water examples. They are consistent throughout. Mixtures, on the other hand, are non-uniform and heterogeneous, like trail mix and salads. They have distinct parts that you can see and separate, and that's the key difference. Understanding this can help you in both cooking and science experiments.